Right, welcome back viewers, welcome back to Builder Science. In this video we're going to be talking about the last part of what now, electrolysis. Now just before we move on, this is we're still on what now, electrolysis what calculation. This is a part 4 of a video series, and we're going to be concluding the entire series for what now calculation involving what now, electrolysis. So if you are new to anything we are going to say here, I advise you just watch the part 1 of this video, part 1, part 2, part 3 to get a full gist of what we're trying to talk about. So now this will be a conclusion video for the whole of what now, electrolysis. Now with that being said, this conclusion aspect we're going to be talking about the what now. We're going to be talking about calculation underneath what electrolysis involving what Faraday's second law. Okay, so now if you are new to this particular video, you can check what the part 1 and I explain everything in details. So now we're just going to be focusing on the word calculation on this one. So now which is going to be concluding the entire video series of electrolysis calculations. Now with that being said, let's look at this particular question here. So now this question says a quantity of electricity liberates 3.6 grams of silver. 3.6 grams of silver. Of course we have silver here, Ag. 3.6 grams of silver from its salt. Okay, so now what mass of aluminium, so now we have silver here, what mass of aluminium would be liberated from its salt by the same quantity of electricity? So now hold on, in this case now we have silver, and we also have we have two metals being liberated here. That means we have two substances being liberated here, silver and aluminium. Silver and aluminium. So now remember what I said from the initial video about the second law of Faraday's second law of electrolysis. I said that the second law states that if the same quantity of electricity is passing through different electrolytes, maybe two of them. In this case now we have two of them, because aluminium and silver cannot be in one electrolytic cell or voltmeter. They are both on different electrolytic cells that are connected together in series. That means the same quantity of electricity is flowing through them. So now from that law that I said that time, if the same quantity of electricity is flowing through different electrolytes, 1 or 2 or 3 or more, the related, I said if the same quantity of electricity is passing through various electrolytes at the same time, and I said the relative numbers of moles. I said the relative numbers of moles is inversely proportional to the ions of their charge. That's their electrons. So now we ended up bringing out the formula from this by introducing a constant. I remember doing that in the previous video, so you can watch that. When we did that, we now have something like this. By introducing a constant, we now have n equals K. We now have n equals Ke. Okay, then we now ended up having n. That's number where n in this case signifying mole. So we now say that if we now have 2 Ks or more, like in this case now we have 2, that means we're going to have the numbers of moles of the first substance liberated, then the electron of that substance will now be equal to the second case, which is in this case aluminium. That means the numbers of moles of the second one, then the electron of the second one. We introduced the formula like this on the previous video, so you can go and look that up. But with that being said, this is the formula we're going to be using to calculate this. So now from this, this is how to detect. This is one very important way to detect any question coming from the second law of electrolysis. That means you have two different substances, two different electrolytes that are connected. Remember, look at this statement. Liberated from what mass of aluminium will be liberated from its salt by the same quantity of electricity. That means the same quantity of electricity passing through them. So I'm going to compare the two cases together, relative comparison. So now with that being said, let's look at this. I told you now that numbers of moles, this means number of moles, this means the electrons and their charges. Okay, electrons. Okay. So now mind you, keep in mind that numbers of moles equals mass over molar mass. Also know that same numbers of moles equals to volume over gaseous molar volume, which we all know is 22.4 dm³. The numbers of moles, we've talked about numbers of moles before, but just keep that in mind. So now with that being said, let's come back to the question. From this now, we have the mass of silver. So now, and look at now, here we have in this question. Yeah, this I brought this out just now. So now this from the question, we have the molar mass of aluminum to be 27, the molar mass of silver to be 108. So now, and we have the mass of silver. So let's focus on silver for a few minutes. Let's calculate the numbers of moles. So now numbers of moles is equals to mass over molar mass, right? So let's calculate the numbers of moles for silver. Let's call silver number 1. So now N will now be equals to what's our mass in this case. Our mass in this case is what now? 3.6 divided by 108. So now if we do that, we have now 3.6 divided by what now? 108. So now from this case, if we should calculate the numbers of moles, that's 3.6 divided by what? 3.6 divided by what? 108. At the end of the day, we now have something like this, something of this sort. I think what? 0.0, that's 0.0333, and just like that. So now we should make do of that. We should make do of this. Now this will not be our moles, our numbers of moles for what now? Silver. That's Ag. Okay. Ag, that's our silver. We've gotten our what? N1 to be what? This will not be our what now? Our N1. Okay, this is our N1. Then for the electron of silver, so now I just brought this one out now for so I can write this because this is not really part of the question, just to make sure we have an idea of what we're talking about here. So now if you look at this properly, let's write for the word. Let's write the electrolytic half reaction of what? Silver. Silver is what now? Ag in its ionic form. Remember, it's electrolysis. So now Ag is usually what? It's usually what? A monovalent what? Atom. So now monovalent ion, rather, positive charge. It will receive what? One electron to now give us what? Our solid what? Silver that we're looking for, our solid silver. So now from this case, now one electron, the numbers of moles of electron is one electron is here. So now our E, which is representing our C from our previous calculation, the E here now is representing our C from the previous calculation. So now it's representing our C which is charge. So now in this case now I'm representing as E. E is equals to what now? 1. Okay. So now from this now we can now go and use the word compare aluminum to find it. So now using the formula, using that formula, N1E1 equals what? N2E2. We now end up having our N1 now will be for silver, that's 0.0333 multiplied by what now? What's our E11 equals to our N2. Our N2 is unknown. For aluminium, we're looking for what mass, we're not looking for the moles. But if we get the mole, we'll put our N2 here like we don't know it. Okay? We don't know our N2. But for our E2, let's look for it. For our E2, let's write the electrolytic half reaction for what now? Aluminium. Aluminium is what? The trivalent what? Metal. So it's going to be +3 in its ionic form. Of course, electrolysis. It will receive 3 electrons, that 3 E minus, to give us our solid what? Aluminium. Okay? So now from this one, we have our E to be what? 3. And numbers of electrons is equal to 3. So that's not what? 3 here. So now from this now we can now find the numbers of moles. Mind you, we are asked to find the mass of aluminium. This represents we have the numbers of moles of aluminium here. By the time we get the numbers of moles of aluminium, we'll be able to what? Use it to what? Convert it to mass. So now N will now be equals to what? If you do this math properly, we now have N2 now be equal to N2 now be equal to 0.0333 divided by what? 3. Okay? And by the time we do that math correctly, that's 0.0333 divided by what? 3. And we have what? Our N2 to be equals to what? 0.0111. Okay? 111 mole. This is numbers of mole. This is the mole for what now? The mole for numbers of moles for what now? Aluminium. Okay, but now they ask us in the question, they asked us to find the what? The mass. Because that's how to find the mass, we convert this mole to mass. Now if we should do that correctly, we should have something like this. Our numbers of mole, recall our number of mole equals to what? Mass over what? Molar mass. Okay, let me represent molar mass by mn. So now our numbers of mole, let's make mass of the formula. Mass will now be equals to mass of aluminium will now be equals to what? Aluminium numbers of moles is what? 0.0111 multiplied by 27 multiplied by what? 27. Okay, which are molar mass. Now let me do that times 27 equals to our mass now equals to 0. We have 0.2997 grams of what now? 0.2997 grams of aluminium. Okay, now watch something, watch closely. 0.299. What do you have that now? Options. You have 2.7 low, 1.2 low, 0.9 low. Look at this part. This is what? 0.3. 0.3. If you should approximate this properly, 0. This 9 now turn into 1. Bring it here. If you approximate properly, that was 0.3 grams of what now? Aluminum. So now our correct answer is what? Option C. Option D rather. Now the same current is passed for the same time, that means second law of electrolysis, through a solution of what now? Silver nitrate and what? Copper 2 sulfate. Of course, two electrolytes, 2 electrolytic cell of voltmeter connected in series. How much silver will be deposited if 1.0 grams of what now? Copper is produced? That means one part of the one electrolyte, one electrolytic cell, the substance deposited in one electrolytic cell was given to us and the other was not. So it's easy and what now? Straightforward. So now first of all let's write the electrolytic half reaction. So now for silver, Ag is in its ionic form. Remember, it's electrolysis, so undergoing one reduction. The metals are undergoing reduction in cathode. So now it's going to be receiving what? 1 electron to give me what? My solid what? Silver. Then for my copper, because for copper to what now? Copper is a transition metal. It has copper 1, copper 2. Okay, but how do I know which one here? Is that for copper to bind with what now? The SO4 radical, it needs what? It has to be what now? Positive to the divalent to what? Copper. So now that will be what? Cu plus 2. Okay, Cu plus 2. So now it's because of undergoing reduction, it will be what? 2e minus, giving 2 electrons. So now for my solid what? Copper. Okay, so now with this being said, I've known my E. My E, in this case now, representing from this formula, N1 E1 equals what? N2 E2. My N1 and E1 will be representing what? Copper, because copper is known in the question. Okay, copper is the what? Entity that was known in the question. So my N1 E1 will be representing copper, and my N2 E2 will be representing what? Silver. So now from this case, now I already know my E2, which is silver, is what? 1. My N1, my E1, which is what? Copper, is what? 2. So now I already know that. So now let's balance something. They gave us what now? They say if 1.0 grams of copper was deposited. So that is to say, for us to what? Calculate with this formula, we have to convert this mass to mole. So mass of copper to mole of what? Copper. So that we're able to include it into this formula to calculate. So now with that being said, let's do that quickly. This N1 now is representing what? N1 is representing copper. Please do not forget that. Okay. Numbers of moles. Let's convert it. Numbers of moles equals to what? Mass over what? Molar mass, right? Molar mass. Now numbers of moles of copper, which is N1, will now be equals to what? What's our mass in this case? 1.0 grams. We divided by what now? What's our molar mass in this case? Molar mass of copper in this case is what now? 63.5. 63.5. So if you do that math correctly, if you do the math correctly, you should have something of this sort. So now 1.0 divided by 63.5. At the end of the day, we end up having numbers of moles of copper to be what? 0.0157. Okay, 57 what? Moles. That's moles of copper. So now we've successfully gotten that. So now we can now go straight to this formula, which is what? N1 E1 equals N2 E2. Like I said, the N1 and E1 will represent that of copper, then N2 E2 will represent that of silver, which is the unknown. Okay. So now with that being said, let's substitute very fast. So now numbers of moles of copper, which is N1, is equals to what? 0.0157 multiplied by what's its electron for copper. The electron for copper is what? 2. So that will be what? 2 equals to N2 is unknown. Okay. By the time we get N2 starts from the numbers of moles of what? Silver. But mind you, I'm not looking for numbers of moles of silver. But we don't really talk about that. So now N2 multiplied by what? My E2 in this case is what? 1. Okay. It's going to be 1. In this case is 1. So now making N2 is the formula. We now have N2 equals to 0.0157 times 2. Okay. So now let's do this math quickly. We have times 2. The time we do that, we now have our numbers of moles of what? Silver. N2 equals to what now? Will now be equal to 0.03149. Okay, 1496. So now if we do like that, we should do something like this. These are numbers of moles of what now? copper. And numbers of moles of what? Oh, sorry, numbers of moles of what? Silver. Okay, mole of what now? Silver. That's Ag. Numbers of moles of what? Silver. But mind you, since we've gotten the numbers of moles of silver, it's not our answer. What we are asked to find is how much silver will be deposited. That means the mass of silver. So now we have to convert this mole back to mass. So we have to for us to get our answer. So now remember, for us to convert it to mass, N2 will equal to what now? Mass over what? Molar mass. Okay? Mass over molar mass. Making mass solve the formula, we now have mass will now be equals to what? Numbers of moles times what? Molar mass. Okay? So that being said, let's just go straight to the point. So now, numbers of moles is what now? 0.031496 multiplied by what's our molar mass for silver? Our molar mass for silver is what? 108. Okay? Now, should do that math correctly. If we should do that math correctly, so now 0.031496 times, multiplied by what now? 108. At the end of the day, we end up having what? We will end up having a mass of what now? 3.401568. Now, if you approximate properly, and mass will now be equals to what now? Let's make it let's say 2 decimal place. To make it 2 decimal place, we have something of 3.40 grams of what? Silver. That was what now deposited. So now, do we have any of such answer there? Our number one, option A says what? 1.7, which is not correct. We have 3.4, and this we have 3.40. So now our answer is what now? Correct answer is what? Option B. So option B should be what? The correct answer. Of course, C and D, they're out of the way. Okay, so that's how to solve question that's relating to the what now? The Faraday's second law of electrolysis. Okay, so now don't forget to hit the like and subscribe button, and also leave a comment if you find the video helpful. Okay, and we'll see you on the next one.